Hello everyone and welcome to Diagnosing Thermistors. In this video we're going to discuss the temperature resistance relationship and we'll see how that works. Typical thermistor failures, referencing temperature using ice water or temperature probe, referencing ambient temperature. Using thermistor charts. We're going to be looking and using a multimeter to check resistance of the thermistor, also to see if it's shorted or open. So Scott, how are you doing today?
Good. Yourself?
All right. So talking about the temperature resistance relationship, we have three types of thermistors that we use. Low temperature, medium temperature, high temperature. Okay. And they all have different ohm reading threshold.
Correct.
For instance, you can't replace a high temperature thermistor with a low temperature thermistor because it's not going to measure, it's not going to control properly.
Okay.
So knowing that, we have, all of our thermistors are negative coefficient.
Okay.
Negative coefficient means that when the temperature drops, resistance value goes up. When resistance value goes down, temperature goes up. So it works that way in that scenario. So the typical thermistor failures that we may encounter, one is if the thermistor is out of range, if it's measuring too low or measuring too high. That's typically a shorted thermistor. Okay. Or an open thermistor, which you will see in an ohm meter as OL, because it doesn't have any resistance to measure there. So that's some of the typical failures. Of course, the thermistor has to be mounted on the tube or on the surface for it to work properly.
Yes.
Okay.
Yes.
So keep that in mind. So now you have a prop here showing how to measure or to reference the temperature of the thermistor.
Correct. So we have two things we can do here in this example. We have a cup with ice water. Make sure, again, a cup of ice with water, and we stick the probe right into it. So, and then our temperature, just making sure that we're reading roughly 32 degrees.
Correct.
And then from there, what we can do is we can connect our meters and our needles. Now, again, to point out, for our connectors, we have to use needle leads.
Absolutely.
Because if we use, you know why we have to use these versus the other?
Yeah, because the standard leads that you get with a meter are much thicker. Okay, so if you look at this connector, the openings that you have to put them in are very small.
Correct.
And only the needle leads will fit in there. If you try to force a standard lead, you're going to break the connector or break the socket that is plugged into at the board, and you're going to have to buy a new thermistor or a new circuit board.
Correct. Nice, thank you. And another example we can use, other than the ice bath, is actually just doing a room ambient temp. So in this case, we have a temp probe, and we taped the actual thermistor right on the probe to get an actual room temperature reading of that. All right. So the next step we would do is actually doing a reading. So what we would do is we would actually go ahead and test, take our needle leads right into the plugs behind.
Yeah, because you can do this test while it's plugged in. You can do it both ways.
Yes.
Actually, it's better if you disconnect the thermistor of the circuit board.
Okay.
And then you can do it either behind the connector, which gives you a little bit more room, or you can do it in front of it.
Okay. So in this case, we are reading 5 point. So I'm going to make sure I'm plugging in all the way. So actually an actual reading. We're reading 5.1. So in that case, and we have to make sure that we're using the right meter because it's actually in kilo ohms.
Right.
So just to make sure
Which is 1,000.
1,000, correct. So in this, if we're reading 5.1, it will be 5,100.
Correct.
So we would reference that with that number, the 5,100 on the chart with what temperature this is reading.
Right.
And the ambient temp in this room with this probe is 74 degrees.
Okay. And to confirm whether that thermistor is good or bad, we would have to find the chart specific to that thermistor in MyLink Drive in the service manual.
Correct.
In the unit-specific service manual.
Yes.
Because again, like you heard me mention earlier, we have several types of thermistors, and they all have different temperature, resistance threshold.
Correct.
So you got to go to the right thermistor, find your temperature, and then go up until it intersects on the curve, and go to your left to find what the ohm reading should be.
Correct. And another good check if this thermistor is also good or bad is if you're reading a 0 or an OL,
Right.
then we got a bad thermistor.
Absolutely. And then again, a shorted thermistor will give you an out of range reading.
Correct.
It may give you, for instance, our ambient temperature thermistor is measuring ambient temperature. So if the ambient temperature is 85 degrees, but you're with your resistance test, taking it to the chart, it tells you it's minus 10, you know
We know
you've
we got a
got,
problem.
exactly, you get a bad thermistor.
Awesome.
So that's pretty much covers, it's the simplest component in our systems that we can check.
And it's all over our system too.
Absolutely.
Yes.
So thank you for watching, and we'll see you on the next video.
Thank you.